Hello YouTube, and today I'm going to continue my representation of binary numbers series. In my last video I have talked about how do we convert sign numbers, which is positive and negative numbers, in binary, and one of the ways was the sign magnitudes. The problem with the sign magnitude is that we have two numbers, which is 1 and 3 zeros and 4 zeros, is actually both of them is 0, so it's a repeated thing and it's a waste of memory. Another thing to remember in the sign magnitude is that the 1 was for negative numbers and the 0 is for positive numbers, and this is usually the case with the sign magnitude. But so they have invented something called excess notation, and excess notation is another way to represent binary numbers to decimal numbers, especially the positive and negative numbers. And the thing that we have done here is that the 0 is actually for negative numbers, so this is a negative number. And then when it's a negative number, you remember that this is 2 to the 0, which is 1, and this is a 2, and this is a 4, and this is an 8. So when it's a negative number, it's negative 8. When it's a negative 4 zeros with only negative 8. So it's kind of similar to the previous notations. The 3 zeros and 1, it's the same thing. It's a negative number, so we know from the 0. And then we actually know that we have a 1, which is a positive 1. So it's going to be a negative 7. What about the next one? A 0, which is again a negative number, negative 8, and then you have a 4 and a 1, which is a 5. So this number is going to be negative 3. This is where it comes interesting. 1 and 3 zeros is actually a 0, because this is a positive number, or it's a 0. A 0 is not positive or negative. What about this one, a 1 1 0 0? We know that it's a positive number, so we can put the plus. Excuse me, but this is a plus. And then we have a 4, so this one is a positive 4. This is a positive number, and then we have a 4, and then we have plus 1, so it's a 5. What about the last one? 4 ones is 7, a positive 7, because this is a 4, a 2, which is a 6, and then you add it to the 1, which is 7. One observation here is that it's very important to know how many bits you are in, because if it's a 5-bit, then 1 0 0 0 0 is the 0 as an integer. So it's pretty obvious that we have fixed the problem with the repeated 0 here, but there is one small issue with excess notation, which is that it's not obvious. The calculation for it is not direct. You have to think about it. So there is another representation, which is 2's complement, which is mostly more important, I think, than excess notation. But this is one way to represent binary numbers into integer numbers. Thank you for watching, and I hope this video was helpful.